Okay guys, I nak you tengok this is how you build your Maxwell-Boltzmann distribution curve. Ni macam mana kamu nak draw Maxwell distribution curve, where your y-axis should be number of molecules ataupun number of particles. Okay, your x-axis should be kinetic energy. So kalau kinetic energy, tahu-tahu je lah dia punya unit dia ialah kilojoules per mole ataupun joules per mole. And then I want you to letak scale dekat your x-axis ni, scale EA. EA tu apa? Activation energy. Okay, so this wajib ni letak EA. EA tu adalah activation energy. Okay. Lepas you dah lukis y-axis, x-axis, scale of activation energy at your x-axis, I want you to draw two different curve, okay, which this curve represent T1, this curve represent T2, di mana temperature yang kedua must be higher than temperature yang pertama. Bermaksud temperature yang kedua ni, contohnya kalau temperature kamu 400 Kelvin, okay, temperature yang pertama ni mesti lagi rendah daripada temperature yang kedua. Okay, contohnya temperature pertama ni ialah 100 Kelvin. Okay, so bila after that you and then you kena lukis bila the ones yang ada higher temperature ni, dia punya curve tu kena lagi wider, lagi luas berbanding the lower temperature ni, temperature yang rendah ni punya curve. Okay. Okay, kenapa you mementingkan scale activation energy ni? Alright, sebabnya, okay, for a reactant, okay, untuk reactant bertukar kepada produk, okay, untuk reactant bertukar kepada produk, you mestilah buat effective collision kan? And one of the requirement of effective collision to occur is the colliding particles must have enough energy that is known as activation energy. Okay, you kena ada number of molecules ataupun number of particles yang melepasi activation energy. Sebab itu adalah syarat-syarat effective collision berlaku. Itu adalah syarat-syarat reactant nak bertukar kepada produk. Okay, di mana number of particles tu kena melepasi activation energy. So that's why you kena buat scale activation energy ni ya. Lepas tu sepanjang activation energy ni, okay, this is garisan activation energy. Because kita mementingkan number of molecules ataupun number of particles yang melepasi activation energy untuk kamu punya reaction tu bergerak daripada reactant kepada produk, and itu adalah salah satu syarat effective collision. Okay, and then okay, sekarang ni area under the graph, area under the curve untuk temperature yang kedua dengan temperature yang pertama ni, itulah kita namakan dia sebagai number of molecules with energy greater than or equal to activation energy. Okay, ni simbol matematik ni, simbol matematik greater than or equal to activation energy. Kenapa kena ada equal to juga? Kenapa tak boleh greater than? Sebab you akan lorek start daripada EA ni sampai ke sini. Okay, so that's why kalau let's say temperature, temperature mathematical expression dia kena greater than, tak boleh equal to. Okay, mesti macam temperature yang kedua ni mesti memang kena higher than temperature yang pertama, tak boleh sama dengan temperature yang pertama. Okay, and then next, okay, area under the curve ni melambangkan number of particles ataupun number of molecules yang ada energy greater than ataupun equal to activation energy. Ni EA tau, bukan E1, bukan E2, EA. EA apa? Activation energy. Kenapa Mr. emphasizekan this thing sangat-sangat? Sebab some of my students, okay, kan even letak EA pun, dia ingat ni E1, ni E2 just because of this is T1 and T2. I don't want you to do that. This is EA, okay, activation energy. Alright, and then the area under the curve ni, kalau if you look at temperature yang pertama, okay, selepas dia melepasi activation energy ni, This is the only area under the curve for T1 yang melepasi activation energy. Okay, so if you look dari sini sampai sini, this represents the number daripada sinilah sampai sini. Okay, this area under the curve ni represent the number of molecules with energy greater than or equal to activation energy at temperature yang pertama. So you tengoklah number of molecules dia yang melepasi activation energy ni sikit ke banyak? Sikit. Okay, sikit. While the area under the curve of temperature yang kedua yang melepasi activation energy ni is going to be daripada sini sampai sini. Okay, so daripada sini sampai sini. Okay, okay, sepanjang-panjang bawah graf dia ni. Okay, sepanjang-panjang ni. You nampak tak ni? Okay, sepanjang-panjang ni. Okay, this whole thing ialah area under the curve for T2. Ada my student, dia buat mistake. Dia just lorek sampai sini je. Okay, dia buat mistake, dia lorek macam ni je sampai sini. Dia fikir ni bukan area under T2. Dia fikir, okay, dia lorek macam ni je. Because dia fikir this one is not area under the curve for the curve T2, area under the curve temperature yang kedua. No. Okay, you kena tarik sampai bawah. Okay, you tarik sampai sini. Because dari sini sampai sini, okay, daripada this until here ialah area under the curve untuk temperature yang kedua at a higher temperature. Okay, from here till here, this represents area under the curve of T2, bermaksud this whole thing. Okay, yang Miss lorek kamera ke semuanya tu, it is actually number of molecules with energy yang greater than ataupun equal to activation energy at a higher temperature. You tengok ni, at a higher temperature banyak kan number of molecules yang melepasi activation energy ni. Lagi berbanyak berbanding at lower temperature. So kiranya bila temperature tu increase, number of particles yang ada energy that is greater than and equal to activation energy pun banyak compared to T1 ni. T1 tu kecil ni je. Okay, and as a result, bila number of molecules ataupun number of particles yang ada energy greater than or equal to activation energy ni banyak dekat temperature yang kedua, makanya the chance untuk berlaku effective coalition tu pun increase. Okay, so bila the rate of effective coalition increase, makanya the rate of reaction pun will be increase as well. Okay, dalam soalan tutorial akan ada soalan yang dia suruh kamu explain the effect of temperature on the rate of reaction by using a Maxwell-Boltzmann distribution curve. Okay, so what I want you to do is you're gonna draw this whole thing, okay, this whole Maxwell-Boltzmann distribution curve punya graph, and then you write down this explanation. Okay, so this is how you draw the Maxwell-Boltzmann distribution curve. Okay, I want you to insert dia punya title. Okay, so title dia adalah Maxwell-Boltzmann distribution curve punya graph. Okay, and then your y-axis, okay, draw your y-axis and mention your y-axis as the number of molecules ataupun number of particles, and then your x-axis ialah kinetic energy. Okay, unit in kilojoules per mole. Okay, I want you to okay, this misalkan tick lah mana yang penting. Ni penting, y-axis penting, label on y-axis penting, your x-axis penting, label on your x-axis pun penting, and also the scale dekat you punya x-axis, which is activation energy, EA. Okay, ni pun penting, EA. Please buat scale EA. EA tu adalah activation energy. Okay, ni pun penting. Okay, I tak nak you miss anything pun from here. And then, ni pun penting juga. Buat T1. T1 ni ialah temperature yang rendah sikit daripada T2. Di mana T1 ni dia punya curve tu lagi kecil berbanding T2. T2 tu higher temperature. So, the higher the temperature, the wider the curve. Okay, so dua curve ni pun penting. Okay, dua curve ni penting, and then ni pun penting. You kena bagi tahu yang temperature yang kedua ni is higher than temperature yang pertama. Okay, this one point, this statement is important too. Okay, sebab kita nak tunjuk yang temperature kedua ni ialah temperature yang tinggi, and that's why dia ada wider curve. Alright, and then next is wajib tu untuk you loretkan, okay, lorate area under the curve untuk curve temperature yang pertama, okay, which is daripada sini sampai sini. Okay, so contohnya you lorate dengan color biru. So lorate lah dengan color biru. And then you lorate area under the curve of temperature yang kedua yang melepasi activation energy, which is daripada sini sampai sini. Okay, daripada sini sampai sini. So you lorate lah the area under the curve yang melepasi activation energy untuk temperature yang kedua. Okay, so sini pun kena lorate juga. Okay, after you dah lorate, you bagi tahu. Okay, you letak box kat sini. This blue box represent the number of molecules with energy greater than or equal to activation energy at T1. Okay, this red box, okay, yang you dah loretkan red box ni pula, is the number of molecules with energy equal to or greater than activation energy at temperature yang kedua. Okay, dua benda ni pun penting. Okay, these two things pun penting. So ada berapa item yang penting untuk you lukis the Maxwell-Boltzmann distribution curve? Ada 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 12, 13. Yang shaded area ni pun penting. So ada 13 items yang you cannot miss at all when drawing the Maxwell-Boltzmann distribution curve. Okay, so bila nak menerangkan this Maxwell-Boltzmann distribution curve, you bolehlah bagi tahu this diagram shows the Maxwell-Boltzmann distribution curve for a gas at two different temperatures, which is T1 and T2, and the shaded areas represent the number of molecules ataupun number of particles yang ada kinetic energy that is equals to or greater than activation energy EA. EA ni ialah activation energy. Okay, and then the higher the temperature, the greater the number of molecules will move at a high speed with a higher energy. Therefore, more molecules can achieve the activation energy for a reaction to occur, and dia akan membuatkan the rate of effective collision increases, and therefore the rate of reaction will increase as well. So I want you to follow everything bila you nak kena terangkan pasal effect of temperature by using the Maxwell-Boltzmann distribution curve. Okay, you ikut je semua benda ni, dia punya lukisan and also dia punya explanation. Okay, for example, kalau you ada dua different temperatures, di mana temperature yang pertama 350K, temperature yang kedua ialah 400K. So bila soalan suruh kamu explain the factors of temperature that affect the rate of reaction by using Maxwell-Boltzmann distribution curve and also using the information given, you pun lukislah y-axis, number of particles, x-axis is your kinetic energy. Okay, kinetic energy in kilojoules per mole, and then don't forget to put scale yang melambangkan EA. EA tu apa? EA tu ialah activation energy. Okay, and then if you look at here, this is area under the curve untuk temperature yang kedua. Okay, which daripada sini sampai sini. Okay, this is area under the curve untuk temperature yang kedua. Okay, manakala this is the area under the curve untuk temperature yang pertama. Daripada sini sampai sini. Okay, so contohnya I loretkan untuk area under the curve for temperature yang pertama ialah dari sini sampai sini. Untuk area under the curve untuk temperature yang kedua ialah daripada sini sampai sini. Okay, ni sampai sini. Area under the curve untuk temperature yang kedua yang melepasi activation energy. So kenapa penting kita nak shade the area number of particles yang melepasi activation energy ni, sebab itu adalah syarat-syarat untuk kamu meneruskan the reaction, to proceed the reaction daripada reactant jadi pada produk, which that is one of the characteristics of effective collision. Okay, and after that kamu pun labelkanlah yang color merah ni ialah number of particles with energy greater than or equal to activation energy at T2. Okay, while this shaded area pula ialah number of particles with energy that is greater than or equal to activation energy at T1. Okay, lepas tu you can see that the area under the graph yang melepasi activation energy is bigger for the curve yang temperature yang higher ni, yang 400K ni. Of course lah, sebab the higher the temperature should be more molecules, more number of particles yang melepasi activation energy untuk the higher temperature. Okay, indicating that there are more particles. That means you ada banyak particles yang melepasi activation energy untuk temperature, untuk higher temperature T2. Okay, and then area under the curve ni is actually proportional to the number of reacting particles. Okay, tapi sebab kita lorek bawah yang melepasi EA je, so yang penting ni dia kena melepasi activation energy. Yang sebelum-sebelum ni kita tak kisah pun. Okay, and then at any temperature there is actually a wide range of energy possessed by reacting particles. So take the shape of the graph is actually dia akan ikutlah temperature. Kalau temperature tu rendah, shape of the graph itu, shape of the curve itu should be thinner, should be lagi kecil sikit berbanding temperature yang higher, should be wider. The higher the temperature, the wider the curve. Okay, cuba you buat try this ni. Dia bagi tahu ni, the curve ni indicates energy possessed by same reacting particles at 3 different temperatures, which is 315, 350 and also 390K. So dia suruh kamu label each of the curve with its corresponding temperature. From previous slide, Miss bagi tahu apa tadi? The higher the temperature, the wider the curve. So who has the highest temperature here? 390K is the highest temperature, 315K is the lowest temperature. So I expect 390K ni punya curve should be wider than the widest, ataupun wider than 350 dengan 350K punya temperature. So I suspect this curve kan, this red curve should be 390K. Okay, lepas tu yang color hijau punya curve ni pula ialah should be 350K. Okay, this one should be 350 Kelvin, and yang paling kurus ni, yang paling tak membesar dia punya curve tu is the lowest temperature, which is 350K. Okay, sebab kat sini the higher the temperature, the wider the curve. Okay, there are actually two ways yang you boleh increasekan the rate of reaction by manipulating the effective collision. Okay, benda ni akan related to activation energy. Okay, so apalah benda yang related to activation energy? Ada dua actually factors yang relate dengan activation energy. So the first one, temperature. Okay, temperature kan kita ada relatekan dengan activation energy. Kan kita belajar tadi pasal Maxwell-Boltzmann distribution curve tu. Okay, di mana kamu kena buat curve yang menunjukkan number of particles melepasi garisan activation energy. And another thing ialah pasal catalyst. Catalyst pun dia ada mention pasal activation energy. Okay, so the way you want to manipulate the effective collision is first by increasing the temperature. Sebab bila you increasekan the temperature, the number of particles yang melepasi activation energy ni akan jadi bertambah. So bila jadi bertambah, makanya the chance of effective collision will be increased, and then you will increase the rate of reaction. Okay. Sebab kenapa bila kita cakap nak manipulate effective collision ni, kita kena relatekan dia dengan activation energy. Sebab you ingat tak lagi, ada dua karakteristik yang akan menyebabkan effective collision, which is the first one ialah you kena colliding particles tu kena ada energy yang minimum, which is we call it as activation energy. And also yang kedua, the colliding particles kena collide at the right orientation. Okay. Tapi bila kita cakap pasal factors yang affect the rate of reaction, tak adalah kita nak cakap pasal particles tu punya orientation. We are talking more about the activation energy. Okay, we are talking more about the activation energy. So that's why ada dua faktor je yang main pasal activation energy, temperature dengan catalyst. Lagi satu, kalau let's say you add a catalyst, you akan speed up the rate of reaction sebab catalyst ni dia provide alternative pathway, dia akan provide the new pathway, dia akan provide shortcut yang di mana kamu akan lowerkan the activation energy. So bila you lowerkan the activation energy, that is one of the hack untuk kamu manipulate the effective collision. Okay. Okay, previously Miss ada ajar macam mana kamu nak explain the effect of temperature on the rate of reaction by using Maxwell-Boltzmann distribution curve. Okay, another way untuk kamu explain pasal effect of temperature on the rate of reaction ialah melalui Arrhenius equation. Okay, so apa tu Arrhenius equation? Arrhenius equation dia akan show the relationship between the rate constant, K ialah rate constantnya, with temperature and activation energy. Okay, so bila soalan tanya, soalan definition lah selalunya, dia suruh kamu define Arrhenius equation, state Arrhenius equation. Yes, you can use this equation di mana K ialah rate constant equals to A ialah in this case Arrhenius constant. A ni bukan reactant lagi. A di sini ialah Arrhenius constant. E exponent to the power of negative EA. EA ialah activation energy, R ialah universal gas constant, and T ialah temperature. Rate constant unit tu depends lah pada kamu punya order of reaction. Boleh rujuk kat table Miss pasal zero order, first order, second order, what is dia punya rate constant punya unit, you can find it out. Arrhenius constant, you can find it from plotting and Arrhenius equation punya plot, nanti kita akan belajar about it later. Activation energy in joules per mole, universal gas constant dibagi dalam constant list, and temperature must be in Kelvin. Alright, okay, so kalau soalan definition, memang kalau soalan definition dia suruh kamu bagi Arrhenius equation, you memang kena jawab macam ni. Tapi kalau let's say soalan calculation, you need to calculate any of these items, you kena express it di dalam bentuk natural log, di mana kamu kalikan everything ni, multiply everything in here, you kalikan okay, it's like you kalikan everything dengan natural log. So bila you kalikan everything dengan natural log, so you akan dapatlah this thing, this equation. Okay, tapi kalau soalan yang melibatkan calculation, it is highly advised. Kalau soalan melibatkan calculation, it is highly advised untuk you express dia di dalam bentuk natural log. Okay, di mana you akan bawa turunlah EA ni. Inilah dia yang Miss cakap dekat slide previous tu. Kalau let's say you nak assess the relationship between rate constant, temperature, you lagi senanglah transform je Arrhenius equation tu in logarithmic form. Okay, kalau you transfer equation di dalam logarithmic form, you just natural logkan everything and you will get this equation. Okay, and from this equation, it is shown that when the temperature is high, okay, the rate constant should be high. Okay, so from this equation, it shows that when the temperature is high, the rate constant K is high. Okay. Walaupun sebab apa? Because ni natural log. Walaupun dia 1/t, tapi because this is in a logarithmic form, so dia somehow dia punya relationship between k, okay, relationship between rate constant and t, somehow it would be directly proportional. Because bila temperature ni is high, the term EA over RT ni akan jadi small. As a result, ln A minus EA over RT ni akan dapat big number yang indicates the rate constant tu high bila temperature tu high. Okay, temperature is high. As a result, the rate of fraction, okay, is high at high temperature. Okay, and this fits the explanation of a factor affecting the rate of fraction. Sebab supposedly bila temperature high, rate of fraction high. So bila rate of fraction high, that means rate constant pun must be high as well. So dia fit lah explanation, okay, fits the explanation of factor affecting the rate of reaction based on collision theory for temperature. Sebab itulah Miss cakap, kalau you nak explain further about factors temperature yang affect the rate of reaction ni, you boleh explain melalui Maxwell-Boltzmann distribution punya curve and also Arrhenius equation. Sebab melalui Arrhenius equation, it can be shown that when the temperature is high, the rate constant is high. So bila rate constant is high, that means the number of molecules yang ada effective collision pun will be higher, and therefore the rate of reaction will be high. Okay, so next we are going to go, kita akan tengok pasal Arrhenius plot. Okay, Arrhenius plot ni berguna bila kamu nak menentukan EA ni activation energy, okay, ataupun K rate constant, ataupun Arrhenius constant, okay, based on experimental data via graph. Okay, so kalau you nak buat Arrhenius plot, you kena susun kamu punya logarithmic Arrhenius equation ni yang ln K equals to ln A minus EA over RT. You kena susun dia sampailah you punya y-axis you ialah ln K, x-axis you should be 1/t. Okay, since these two things is the same thing, so you pisahkan je lah EA over R, therefore EA over R ni you boleh dapati melalui gradient. Okay, so EA over R ialah M, negative EA over R, ln A ni adalah your y-intercept. Okay, so you susun this logarithmic equation Arrhenius ni into y equals to mx plus c, di mana bila you kena nak buat Arrhenius plot, you kena plot the graph di mana ln K ni ialah y-axis, okay, ln K must be y-axis, and then 1/t must be x-axis. Okay, and the graph yang kamu plot kena obey linear law. So you must have gotten a linear graph yang obey law y equals to mx plus c, di mana m tu adalah gradient, c ialah y-intercept. Okay, and the gradient will be negative EA over R, di mana you boleh carilah you punya activation energy daripada graph you bila you kira dia punya gradient, and then R ni pula you boleh dapat daripada gas constant punya value, which is it is 8.314 joules per Kelvin per mole, and from there you bolehlah dapat your activation energy, and the value you kena make sure energy tak akan ada value yang negative. Value of activation energy must always be positive. Okay, sebab energy unit mana ada energy yang negative, energy always positive. Lepas tu the value of Arrhenius constant pula you boleh dapat daripada y-intercept. Okay. Okay guys, let's look at this example. Dia bagi tahu in an investigation of the effect of temperature on rate constant. Okay, you tengok kat sini keyword dia temperature and then rate constant. Okay, so anything yang melibatkan temperature dan rate constant, you kena ingat this must be related to Arrhenius equation. Okay, sebab kenapa in Arrhenius equation temperature is directly proportional to the rate constant. Alright, and then next dia bagi tahu okay lah, this process of isomerization di mana reactant you cyclopropane, product you propene, and you obtain this following data, and dia suruh kamu buat graphical method to determine the activation energy and Arrhenius constant. So dia suruh kamu cari EA, activation energy, and Arrhenius constant A. Okay, in this case your A is not reactant anymore, your A ni ialah Arrhenius constant. Okay, so macam mana kamu nak buat graphical method untuk determine these two things? So ingat balik Arrhenius equation. Arrhenius equation ialah Arrhenius equation ialah K rate constant is equals to Arrhenius constant kalikan dengan exponent to the power of negative EA over RT. Okay. Tapi Miss cakap ni by definition. Kalau you nak buat in calculation, you kena expresskan dia in logarithmic form where you will get this. And then bila you nak buat Arrhenius plot, you kena remember when you want to do the Arrhenius plot, okay, your y-axis must be natural log K. Your x-axis must be 1 over T. Okay. So you susunlah this equation sampailah you dapat y equals to, okay, sebab it's going to be a straight line graph. So it's going to be equation yang kena follow, kena obey y is equals to mx plus c. Di mana you punya y-axis ialah ln k, x-axis 1 over t, your m is going to be negative EA over r, and your y-intercept is going to be natural log A. But if you look at from the following data, dia hanya bagi kamu info on the temperature and also rate constant. Tapi x-axis you kena 1 over t, y-axis you kena ln k. So apa yang you kena buat? Kira lah. Okay, you buat another one table, another extra table untuk x-axis dan juga y-axis. Untuk 1 over T dan juga ln K. Okay, bila you buat 1 over kan dengan temperature, you akan dapat everything ni kalikan dengan 10 kuasa negatif 3. So, you nak shortcut kan untuk dapatkan graf yang lawa. So, you buatlah 1 over T is equals 1 over T ni kena kalikan dengan 10 kuasa negatif 3 per Kelvin siap-siap. Lepas tu, bila you nak buat graf, okay. In this question, the question asks you to find the activation energy and also Arrhenius constant. Okay, so sekarang ni macam mana you dah dapat activation energy? You boleh obtain activation energy melalui gradient. So bila let's say I know that your graph paper is very limited. Okay, and then bila you nak cari gradient, you kena buat scale tu cantik-cantik supaya you dapat gradient yang lawa. Okay, supaya you have a higher chances to find a good gradient so that you can get a good activation energy punya range. Okay, so kat sini that means you kena buat 2 graph. Okay, you need to do 2 graphs. Okay, graph yang pertama, kamu kena panjangkan dia punya x-axis punya scale so that you will get a better gradient. Graph yang pertama, you can get a better gradient. Okay, better gradient for the graph so that you boleh dapat better gradient supaya you boleh dapat activation energy yang bagus. Okay, and then the second graph is gonna be graph yang you boleh dapat better y-intercept. Okay, so for the second graph, bila you ada graph paper ni kan, this is your y-axis, this is your x-axis. You kecilkan, okay, you kecilkan your scale of your x-axis supaya you dapat sampai y-intercept. Okay, so you need 2 graphs. Bila soalan tanya dua-dua, soalan nak dua-dua. Kalau soalan nak salah satu, you tengoklah. Kalau soalan nak activation energy je, you buat je lah satu graph yang di mana you akan dapat better gradient. Kalau soalan suruh you cari y-intercept, dan you buatlah graph di mana you kecilkan you punya x-axis scale you supaya you dapat better y-intercept. Alright, So in this case, okay, kita look at the first graph first. Graph untuk kamu cari activation energy, di mana you kena tulis title, y-axis you ialah ln K, x-axis you ialah 1/T, kalikan dengan 10 kuasa negative 3 K Kelvin per Kelvin. Okay, so you will get this straight line graph. And kalau nak cari gradient, okay, gradient is equals to y2 minus y1 bagikan dengan x2 minus x1. I know that gradient ni kalau boleh you cari biar kotak tu lebih daripada 4 atau 5, something like that lah, biar besar. Okay, tapi untuk jalan selamat, you boleh treat yang the first column here as this one, it can be x1, this can be y1, and this can be x2, and this can be y2. Okay, to be safe je lah kalau nak jalan selamat. And after that, once you have found your gradient, which is your gradient ialah negative 34089.6, and you know that your gradient, okay, kan gradient you kan is equals to negative EA over R. So gradient bila you kira dapat negative. And then gradient pula equals to negative EA over R. So what can you do ialah you can cancel out the negative here. Okay, you can cancel out the negative here. And then you bawa lah gas constant 8.314 ni, bawa ni atas. And you will get your activation energy in joules per mole. Okay, tapi if you want to change it into kilojoules per mole, senang je, bahagi je dengan 1000. And then you akan dapatlah jawapan you in kilojoules per mole. Okay, next ialah untuk cari Arrhenius constant A, you kena cari y-intercept. You know that y-intercept is equals to ln A, and then it is equals to 35.54. Kalau ikutkan, you buat second graph, suppose you punya y-intercept tu you dapat around 35.54 lah. Okay, so untuk kira A, you exponentkan this. So you akan dapatlah 2.7216 exponent 15. Okay, tadi kita learn about Arrhenius plot. Now it is about Arrhenius calculation. Okay, Arrhenius calculation ni contohnya kalau kamu nak kena cari activation energy bila dia ada dua rate constants and dua different temperatures. Okay, if let's say you diberi dua temperature dengan dua rate constant, okay, you kena guna simultaneous equation yang akan form this one whole equation. Okay, so equation ni you kena hafal. Okay, tapi kalau macam mana you dapat equation ialah from this lah. Kerana kalau let's say if you dapat rate constant yang pertama dengan temperature yang pertama, you labelkan this as the first equation, and then kalau you ada rate constant yang kedua, you dapat temperature kedua, you labelkan dia as the second equation, and then 1 minus with 2, and you will get this equation, di mana in this equation, okay, there will be no Arrhenius constant pun. Okay, because you dah cancel out the Arrhenius constant. Yang tinggal hanyalah ln K1 minus K2. Bila K1 minus K2 jadilah dia ratio of rate constant yang pertama dengan rate constant yang kedua. Equals to EA, activation energy, divide by R. Okay, and kalikan dengan 1 over temperature 2 minuskan dengan 1 over temperature 1. Okay, for example, kalau let's say you have an experiment di mana you akan investigate the effect of temperature on rate constant, where you have two different temperatures and two different rate constant in unit as -1, okay, per second. So use the data above to calculate the activation energy for the reaction to occur. So please remember back equation yang before this. Okay, this is the equation yang melibatkan dua rate constant and dua temperature. Okay, you need to memorize this. And temperature tadi, table tu dibagi in degree Celsius, so you need to change it into Kelvin. Alright, so once you have changed it into Kelvin, masukkanlah your rate constant untuk temperature yang pertama dengan rate constant untuk temperature yang kedua, and you will finally get your activation energy in unit joules per mole. Okay, so kalau let's say you kira-kira ni you sebenarnya akan dapat unit joules per mole. You can only get unit kilojoules per mole if let's say you divide this by 1000. Okay, kalau you divide by 1000, barulah you akan dapat kilojoules per mole. So what I would like you to do is to try your understanding. You can do this question, and this question. So I think that's all for subtopic 1.3.